Hello, this is March 8th, Asynchronous, and this is about a hypothesis test for one proportion. All right, so this first slide is just a little bit of review on kind of our language around what a hypothesis does. So just like a trial, right, we have kind of this assumption of innocence, that's our null hypothesis, and then our alternative is really that we're trying to show something different, less than, greater than, or not equal to, and that's really what we're trying to show. It's the same as kind of that guilty uh, sentence we're trying to get for. So our evidence, and actually in questions it'll often say, is there evidence of this being different? That's what the hypothesis is doing. So we basically use our sample to then calculate a p-value, and then we compare, right, our p-value to our significance level, that reasonable doubt. And the guilty is kind of this: we reject the null, there is evidence of the alternative, and the not guilty, we get kind of like a large p-value, we fail to reject, and there's not enough evidence. You can go back to the slide, a little bit of our symbols. This is in the attached slideshow, just what our null, our alternative, our population parameter. This is usually described in words. We don't know it. We're trying to get some information about it. Our p-hat is our sample proportion, our statistic. Our p-value is a probability of that statistic given the null is true. It's an area on the curve. And then alpha is our significance level. What we're going to do, our basic rundowns, we're going to be going over a z-test for one proportion. Our z-test, z procedures are what we use for proportions. Our state, you state the parameter. If we have one proportion, we'd say p equal the proportion of, and then insert your context. Our HO is that p is equal to some number. We sometimes refer to this as p with a little zero, or p naught, or p null. And then our alternative is that it's either less than, greater than, or not equal to that same number from the null. Alpha is our significance level. If we don't know what it is, a lot of times our standard is 5%. Our plan, we check the three conditions, pretty much the same, right? Our random, we check, was there a random sample, a random assignment? Independent, we have a large enough population, so the sample is less than 10% of the population. Our large counts, this is a little deviation from our confidence intervals, and here we use the null value. So we take our sample times the null value, and we get that, and we check to see that that's greater than 10, and then our expected failures, again, the complement, n times the complement, and see that that's greater than 10. The name of the test, we've done a z interval for one proportion, a z interval for two proportions. We're now doing a z test for two proportions. So this particular one is a z test for one proportion. And this z statistic, it's a comparison. It's called the test statistic, and it's comparing, well, how's the sample compared to the null hypothesis? I subtract, right? I calculate the difference. How different are they? And then I divide by the standard deviation, which tells me the number of standard deviations from the null, right? I need like sort of a scale, and the scale I'm always using is that I measure in standard deviations. So this is called the z statistic, or test statistic. Our p-value is an area. If our alternative is less than, we're going to have a lower tail area. If our alternative is that the proportion is greater than, we have an upper tail. If it's just not equal tail, I actually end up with two tails. And really here, I had mentioned this is a less sensitive test because the area is really twice these other formulas. And then our conclusion, we kind of check the size. When we have a small p-value, we reject the HO. We throw the fish back, right? So we compare it to the alpha. It kind of looks like a fish. If it's small, we reject. And this is the statement we'd have: because the p-value is less than alpha, we reject the null hypothesis and do have convincing evidence for whatever the alternative is in context. Go to the question stem for that. Our p-value is greater than alpha. I have a big fish. I fail to reject, right? I keep that fish. Because the p-value is not less than alpha, we reject the null hypothesis. Okay, so when our p-value is greater than alpha, we fail to reject the null hypothesis and do not have convincing evidence for the alternative in context. Here's an example we'll go through. Suppose there's a CEO that claims that 70% of the company's 1 million customers are very satisfied. 100 customers are surveyed using simple random sampling. The result, 63 of the 100 are very satisfied. Is there evidence that there are not as many satisfied customers as the CEO thinks? Okay, so the first clue I'm going to highlight here in the question is that is there evidence? Statistical evidence means a hypothesis test. And whenever you're asked this, even if it's followed by just open space, you are required to do all 4 steps of a hypothesis test. So the state plan, do, conclude. When I break it down a little more, if I look at this first part, this claim of 70%, this is our null. Here, this million customers, that's our population, right? All of the customers. Here, this is our sample information. So we're going to put all these pieces together and go through our 4 steps. For the state, I'm going to start P equals the proportion of customers who are very satisfied, right? And you could put it's of all million. This will satisfy that first state. My HO, my null, is that the P equals 0.70, right? That it's that claimed 70%. Not as many satisfied customers, right? That is really less than. And that the word not as many indicates less. The problem didn't specifically state a significance level, so I'll just use 5%. All right, next, my conditions, random. Yep, they took a simple random sample of the 100 customers. Independent, sure, 100 is less than 10% of the million customers, right? I could calculate it, I get it's like 0.001%, right? So that's definitely less than 10%. For my large counts, I'm going to use my null. Out of the 100, I'm going to expect 70, right? 100 times 0.7 is 70, which is greater than 10. 100 times 0.3 is 30, which is greater than 10. The name of the test, and this is important. This, in all the rubrics, it says that you can either name the test or show the formula. You don't have to do both. I will routinely do both, hopefully to like bring understanding, but naming the test is fine. So our formula, the first part, I'm just going to calculate my p hat, my sample, because that's really what I'm needing to compare. I'm needing to compare the sample proportion to my claimed null proportion. So in this one, I get 0.63, just 63 divided by 100. And here's that comparison calculation. I take my sample value. How does it compare to the null? Right here, so it'd be 0.63 minus 0.7. It's 7% less, right? 0.07. And then I divide. How many standard deviations is that? Well, I divide, right, square root 0.7 times 0.3 divided by 100, and I get negative 1.52. That means I have an observation that is 1.52 standard deviations below the mean. So if I look at that on this curve, right, 0.7 is what is my claim. And then I'm saying, hey, I'm lower by 1.5 standard deviations. There it is right there. The p-value is the calculation of this error. How probable is this sample if the claim is really true? And we're going to go over using Statlet next class. When we enter it in there, we get that this z-score, is going to give a p-value of 0.063. So the area over here is 0.063 or 6.3%. So now I'm going to make my my conclusion. I pulled this up because this is really handy. I'm going to say, well, is the p-value less than alpha or is the p-value greater than alpha? Do I have a little fish or a big fish? Well, if I look at this 0.06, hey, that's bigger than my 0.05. I'm not throwing back this fish. I'm failing to reject. So this is the option down here. I'm failing to reject the null hypothesis. And I will copy this sentence. Because our p-value of 0.063 or 6.3% is greater than alpha equals 0.05 or 5%, we fail to reject the null hypothesis, and that there is not convincing evidence. Here's where I go back to my problem and I say, I'm going to copy from the question. There's not convincing evidence that there are not as many satisfied customers as the CEO thinks. So I've gone back through. All right, so we're going to have a lot of time to practice this, but I hope this was a good sort of like solid example so that it'll make more sense and you'll be ready to practice when we get to class. All right, everybody have a great day and I will see you on Wednesday.